Dear students, welcome to this video. In this video, we are going to solve some more problems based on continuity of the function which are collected from your previous year question paper. Okay, so what is the continuity of a function at a point? As we have discussed earlier, a function is continuous at a point, given point x equal to c, if and only if limit extends to c fx equal to f of c. That is your functional value, and this is the limiting value of the function as x tends to c. Okay, functional value means the value of the function when x is exactly equal to c, and the limiting value means when x tends to c, then what is the value to which f of x becomes closer and closer. Okay, if these two are equal, then the function is continuous at the given point x equal to c. In simple meaning, the continuity of a function at a given point means while drawing the curve of that function through that point, you need not have to lift the pen. Okay, you can draw that graph without lifting the pen, okay, through that point. So let us do a problem that is collected from your previous year question paper. This is just test the continuity of the function at x equal to 1 where fx is defined as this. When x is greater than or equal to 1, then fx equal to 2x minus 1, and when x is less than 1, then fx equal to x. Okay, and this is from your 2015 summer, which bears 7 marks. Okay, then let us solve. Answer: given fx is equal to 2x minus 1 when x is greater than or equal to 1, and fx is equal to x if x is less than 1. Okay, and we have to test the continuity, and we have to test the continuity at x is equal to 1. For this, we have to first find the functional value, that is the value of the function. Functional value, that is the value of the function when x is exactly equal to 1. As we have defined here, when x is equal to 1, greater than or equal to 1, fx equal to 2x minus 1. So just write here that when x is equal to 1, then your fx is defined as 2x minus 1. Then just find out the value of the function at x equal to 1. We have to just put 1 in place of x here. Okay, that is your, after calculation you can get 1. Okay, this is your functional value. Now it's time to find out the limiting value, that is limiting value, that is when x tends to 1, when x becomes closer and closer to 1, or x becomes approaches to 1, then what is that value to which f of x approaches. Suppose this is your 0 and this is your 1, then we have to approach 1. Then 1 can goes towards 1 from the left side and maybe from the right side. But when you go towards 1 from the left sides, means x becomes closer and closer to 1 by taking the value less than 1. Okay, by taking the value less than 1. But when that means x tends to, this can be summarized as x tends to 1 minus, that is your left hand, you can get left hand side limit. But when x tends to 1 from the right side, That means x becomes closer and closer to 1 by taking the values greater than 1. Okay. And this can be denoted as x tends to 1 plus. You can get, that is, you can get your right hand side limit. Okay. So first we have to find out left hand side limit. Left hand side limit means x tends to 1 minus. You should goes towards 1 from the left side. 1 minus means x is less than 1, and x is less than 1 means x is less than 1. That in case of x is less than 1, here you have defined f of x is equal to 1. So in place of f of x, here we can write x, and just put the value 1 in place of x to find the left hand side limit. So here you have got the left hand side limit is 1. Then now we have to find out the right hand side limit. Right hand side limit means x tends to that is x tends to 1 plus. You have to go towards 1 from the right side. That means x is greater than 1. And as you have defined here, as x is greater than 1, then fx equal to 2x minus 1. So in place of fx, we can write here 2x minus 1. Then just put 1 in place of x to find out our required limit, that is your 2 into 1 minus 1 is equal to 1. So our right hand side limit is 1 and our left hand side limit is also 1. That means, so here you have got LHL is equal to RHL. That means limit x tends to 1 fx exists and is equal to 1. Okay. So our limit, here we have found that the limiting value is 1 and also our functional value is 1. That means our function is continuous at x is equal to 1. Okay. So just write here that as limit x tends to 1 fx is equal to 1, which is equal to f of 1. So the given function fx is continuous at x equal to 1. Okay, this is our required answer.